Hi, I am Kimberly Doty.
And I am Abby Gorley. We decided to pick the amygdala for our favorite part of the brain presentation. We chose this because it is the basis of emotions in our brain. As we approach our senior year of college, it has become very apparent to us that stress plays a huge part in our everyday lives.
I'm sure you are all curious as to what all the amygdala is. In fact, the curiosity you are feeling about this topic is a prime example of what the amygdala is and does. It is the basis of emotions in our brains. Part of the brain that controls the fear that is almond-shaped, also controls the way we react to certain stimuli or an event that causes an emotion that could be threatening or dangerous. It's the part of the brain to weigh in, controlling and affecting our emotional responses. It controls autonomic responses associated with fear, arousal, and emotional stimulation. It is also connected to many other parts of the brain, including the hippocampus and cingulate gyrus.
The founder of the amygdala is Carl Burdock. In the early 19th century, he discovered an almond-shaped mass of gray matter in the anterior portion of the mammalian temporal lobe, which he called the amygdala. The first anatomical description of the amygdala was made in 1867 by Maynard. Subsequently, a large number of nuclei were added to the amygdala to constitute what is known as the amygdaloid complex. Until this day, the amygdaloid complex remains a subject of intensive investigation in terms of content and evolutionary development, since it is much more complicated than what was previously thought. It is therefore important to know the evolutionary development origin of the amygdaloid complex before we can completely understand its function. As you can see in the image, the amygdala is a very tiny portion of our brain. The amygdala is an almond-shaped set of neurons located deep in the brain's medial temporal lobe. It also forms part of the limbic system.
One of the emotions processed by the amygdala is stress. Stress then turns into what we call fight, flight, or freeze. To go into more detail, to fight is to confront the threat aggressively. Flight means you run from the danger. When you freeze, you find yourself unable to move or act against the threat. Before the fight, flight, freeze response kicks in, something happens to make you feel you're in danger. This threat may be real or imagined. Someone or something may be threatening to cause you physical or physiological harm. As soon as you recognize a threat in your environment, your nervous system immediately shifts into acute stress response. A stressful situation, whether something environmental, a deadline approaching quickly for work, or physiological, such as persistent worry about losing a job, can trigger a cascade of stress hormones that produce well-orchestrated physiological changes. A stressful incident can make the heart pound and breathing quicken. Muscle tenses and beads of sweat appear.
This combination of reactions to stress is also known as the fight or flight or freeze response because it is evolved as a survival mechanism, enabling people and other mammals to react quickly to life-threatening situations. As you can see, fight is associated with irritability, loss of temper, defensiveness. Flight is associated with avoidance, anxiety, and fear, and freeze is associated with numbing, detachment, and giving up easily. The carefully orchestrated yet near instantaneous sequence of hormonal changes and physiological responses help someone to fight the threat or flee to safety. Unfortunately, the body can also overreact to stressors that are not life-threatening, such as traffic jams, work pressure, and family difficulties. The stress response begins in the brain. When someone confronts an oncoming car or other danger, the eyes or ears send the information to the amygdala. The amygdala interprets the images and sounds. When it is perceived danger, it instantly sends a distress signal to the hypothalamus.
Techniques to relieve stress. The first one is relaxation response. It is a way to relax your body to include deep abdominal breathing, focus on a soothing word such as peace or calm, visualization of tranquil scenes, repetitive prayer, yoga, or tai chi. Another one is physical activity. A good way to boost activity is to exercise, such as taking a brisk walk shortly after feeling stressed. Not only deepens breathing, but also helps relieve muscle tension. And the last one is social support. A good social support is to have people who enjoy close relationships with family, friends, and receive emotional support that indirectly helps to sustain them at times of chronic stress and crisis. Persistent epinephrine surges can damage blood vessels and arteries, increasing blood pressure and raising risk of heart attacks or strokes. Elevated cortisol levels create physiological changes that help to replenish the body's energy stores that are depleted during the stress response, but they inadvertently contribute to the buildup of fat tissue and to weight gain, For example, cortisol increases appetite so that people will want to eat more to obtain extra energy. It also increases storage of unused nutrients as fat. Another thing the amygdala plays a role in is memories. The amygdala attaches emotional significance to memories. For example, if you get stung by a bee, your fear response will kick in, and the bad memory will make your senses heighten to bees in the future. This is particularly important because strong emotional memories, such as those associated with shame, joy, love, or grief, are difficult to forget. The permanence of these memories suggests that interactions between the amygdala, hippocampus, and neocortex are crucial in determining the stability of a memory. That is, how effectively it is retained over time. There's an additional aspect to the amygdala's involvement in memory. The amygdala doesn't just modify the strength and emotional content of memories, it also plays a key role in forming new memories specifically related to fear.
Along with the amygdala, there are also related disorders. There's PTSD, anxiety, personality disorders, OCD, and alcoholism. The left amygdala is linked closely to social anxiety, obsessive compulsive disorder, post traumatic stress disorder, and general anxiety. There have also been links to alcoholism and binge drinking. When pertaining to borderline personality disorder, they are shown to have greater left amygdala activity and difficulty classifying neutral faces. With bipolar disorder, they are shown to have smaller amygdala volume and smaller hippocampal volume. Damage to the amygdala can include off decision making, rash decisions, and bigger risks with smaller potential gain. In a study by Benedetto De Martino, 2 women with bilateral amygdala damage showed a dramatic reduction in loss aversion compared with age-matched control subjects on a series of experimental gambles despite understanding full well the values and risks involved. Here are some facts about the amygdala. The word amygdala comes from the Greek word almond. It is also known as the body's alarm circuit. You have 2 amygdalae. A larger amygdala can be associated with higher anxiety in childhood. It seems to modulate all our reactions to events that are very important for our survival. This also plays a role in our sex drive. You can live without part of your amygdala. There are 12 subregions of the amygdala.
In conclusion, the amygdala is a very small part of the brain, but as we can see, it has a great impact on our everyday lives. It is amazing to see the breakdown parts of our brain. We didn't realize how apparent our amygdala is. In general, students in college deal with a large amount of stress. Once again, as college students coming close to the end of the semester, our amygdala is in overdrive. I can almost guarantee that while either you are studying for finals or finishing your favorite part of the brain video, you show or feel some form of stress. Now we all know where stress is derived from and the many other aspects of what this tiny part of the brain does.